Hello folks, welcome back to the next episode of the PC fan controller. In this video, I'm going to go over the breadboarded circuit and we'll look at the AVR code that we are running on the microcontroller. In this setup here, what I have is, I have the ATtiny that is connected to the thermistor and a 10K resistor. So this 10K resistor and this thermistor basically forms a voltage divider that is fed in to the ADC pin on the microcontroller. Then we have an output that we are controlling from the microcontroller that goes in to the base of our transistor, which will control the fan. Now this is just a sample fan that I've used, and we can use a bigger fan when this actually goes into the PC. Now as you can see, there are two distinct supply voltages here. The fan control here is being powered by a 12-volt supply, and the microcontroller is powered via a USB using a 5-volt supply. Also, we are using this USB to TTL device to read the debug statements that are outputted by the microcontroller. In here we also have the 1K current limiting resistor between the output pin of the microcontroller and the transistor. We have a 10K pull down resistor between the base of the transistor and the ground. A diode here connected across the fan to shunt any high voltage spikes that we get while stopping the fan. Even though these are two separate voltages, we still need to have a common ground for all of these, and hence we have a jumper that connects the grounds of both of these circuits together. This is needed, without which we won't be able to control this circuit at all. Now let's look at the working of this circuit. And as you can see in this window, there are two numbers. Please ignore the first number. The second number is the one that we are actually monitoring in our program. And as you can see right now, it's reading around 490. That is the raw ADC value that we are reading of our ADC3. And the scale of this number is from 0 to 1023, where 0 is 0 volts and 1023 is 5 volts. So we are reading something slightly below 2.5 volts at this point. Now, watch the number as I warm up the thermistor by holding it in my finger. I'm holding it in my finger. Watch the numbers on the screen, and then they start to go up. The moment these numbers hit 560, the fan starts turning. Now let's cool this thermistor with the same fan, and after some time, when the number drops, or when the voltage reading drops below 520, the fan stops. And that's all that a fan controller is doing today. Let's try that again. I'm heating it up again, and it turns on. We cool the thermistor. And it turns off when the number hits 520 or anything below that. Now just let's look at the program that I have written for this to happen. Here we are in Atmel Studio, and this is the program that I'm running on the microcontroller, and I'm using basic serial to output the values that we see in the serial monitor. And the two numbers that we were seeing earlier were the value of the ADC SRA register, and the second value was the actual ADC value that we were running off, that we were reading. So let's quickly go through what I've done in this program. First, the usual things where I set the IO pins. I'm using the pin B4 for the output. I'm setting up the ADC here where I'm using the VCC as my reference. And this line basically sets the ADC with a prescaler of divide by 16, which will give us about 125 kilohertz of sampling since we are running at 1 megahertz. Then in our loop, we are selecting ADC 3. That is where we have connected our thermistor. What we basically do is we are just polling on the ADC SRA resistor to complete the conversion, and once it's done, we exit this loop, read the ADC value, then we simply compare it to our fixed value of 560, and then if it is greater than 560, we turn on the fan. If it is less than 520, we turn off the fan. And this is where the hysteresis actually is. So we turn on the fan on greater than 560, turn off the fan on less than 520. And all we do here is we just output the value that we read from the ADC as a string to the serial monitor. We wait for 500 milliseconds and do the whole thing again. And that's about it. So this program is tailored to the circuit that I have developed on the breadboard, which only has one thermistor and one fan. What I'll basically go ahead and do is I'll change this program so that it can support up to 3 thermistors and it can control up to 2 fans. The circuit would be exactly similar what we have in there, except that we'll have multiple fan controllers, or rather two transistors that will control 2 separate fans and 3 thermistors connected to 3 different ADCs on the microcontroller. And that's about it. So the next thing that I'm going to do is I'll design this in KiCad and create a PCB out of it, make the circuit on the PCB, and then we can test it on the actual PC. That is all for this video, folks, and stay tuned for the next video where I'll do the PCB capture. Until then, have a good day.